Hello all, this is Anita. Welcome to the machine learning video lecture series. In this video, we will see the Naïve-based classifier. This is part 2. In part 1, we have already covered Bayes theorem and the conditional probability. So here we will first see what is Naïve-based classifier, then Bayes theorem, then algorithm of the Naïve-based classifier, working of that algorithm. Then we will see some of the applications of the Naïve-based classifier, then advantages of it, disadvantages, and the types of Naïve-based classifier. So one by one we will see. So here what is Naïve-based classifier? So Naïve is a supervised machine learning algorithm based on the Bayes theorem, and that is used to solve the classification problem by following the probabilistic approach. It is based on the idea that the predictor variable in the machine learning model are the independent of each other. It is a probabilistic classifier, which means it predicts on the basis of the probability of an object. So basically here, this Naïve-based classifier is a supervised machine learning algorithm. So machine learning is categorized into two, that is supervised and unsupervised. So here supervised machine learning contain the classification and the regression problem. So this Naive bias falls under the classification problem. And we can say here it is a probabilistic classifier, which means it predicts on the basis of the probability of an object. Now we will see why it is called Naive-based. So it comprises the two words, that is naive and the base. So naive is nothing but it is called naive because it assumes that the occurrence of the certain features is independent of the occurrence of the other feature. And Bayes is called Bayes because it depends on the principle of the Bayes theorem. So this base of this Naive-based classifier is the Bayes theorem. So we will see what is Bayes theorem. So actually this Bayes theorem is already covered in the previous lecture. If you have not gone through that lecture, so please go through it and then come to this lecture. So Bayes theorem is give us the conditional probability of the event A given that the event B has occurred. So this Bayes theorem is work with the conditional probability, or with the help of conditional probability we have derived the Bayes theorem. So this is the formula of the Bayes theorem. So here the probability of A by B, or we want to calculate the probability of A given B. So this is called as a posterior probability, and probability of B given A is called as a likelihood, and this probability of A is called as prior probability. So and this probability B is called as a probability of the event B, that is the marginal probability. So this is the Bayes theorem, and Naive bias is work on this particular theorem. So here you can see the terminologies related to the Bayes theorem. Now we will see how to apply this Bayes theorem to any classification problem. So let's consider, suppose we are having one classification problem. So that classification problem contain the independent and the dependent features. So here we need to predict the class of Y, where the feature vector X, also known as the feature vector, and you can see here these many features are there. So for a particular one record we are having x1, x2, x3, x4 up to xn record, and y is our dependent variable, or this is the output feature we can say, and this is the classification kind of problem. So this y contain yes no type of class labels are there. Now here, so based on that x, we need to calculate the class of y. So this Bayes formula we will be using for this mapping this classification problem. So here you can see now A means it is an event, or we want to calculate the probability of A given B. So A and B both are the events. So here you can see I want to calculate I want to predict the class of Y. So this is my here I want to calculate this Y, and given these many features. So x1, x2, x3 up to xn feature we are giving here, and is equal to, again we are simply mapping this value into the base theorem. So here again you can see y is nothing but our a and all these features are nothing but our b. So probability of, again here we have simplified the formula. So probability of x1 given y, probability of x2 given y up to probability of xn given y, and then probability of the y. So that's why here we have written probability of y, and divided by probability of x1, probability of x2 up to the probability of xn. Now here you can see whatever this formula is there, only we have rewrite this into this format. So here you can see probability of y, summation of I is equal to 1 to n, probability of x of y given y. So here we are giving y and we are calculating the probabilities. So only we have rewritten the formula with this. So now you can see this is the constant term. So this is constant. So we are just ignoring this constant term and we are rewriting it as like this. Yeah, here you can see. So here you can see this is a constant term, and this is for all the values in the data set. So that's why this denominator is not changing and it remains the static. So therefore this denominator we are removing, and here we are introducing the proportionality. So that's why we have written like this: the probability of y given input feature, proportionality symbol, and the similar things we have written. So here you can see that removing that denominator will help you and it saves the time and the calculations. So in our case here the class variable y has only two outcomes. So like yes or no, because it is a classification kind of problem. So that's why we will be taking the maximum value, or if in case our classification is like a multivariate classification, so that time we need to find the class y with the maximum probability. So that's why we are taking the argmax here of all the probability, and using this function we can obtain the class of a feature given the predictors. So now we will see the working of the Naïve classifier. So here the first thing is we are converting the given data set into the frequency table. The second one is generate the likelihood table by finding the probabilities of the given feature. And the third one is use the Naïve Bayesian equation to calculate the posterior probability. So only what we are doing, we are mapping all the data set values into the Bayes theorem or the Bayes classifier equation. So here you can see this is the problem statement I have taken. So we have a data set and that data set is a weather data set, and based on that weather condition we want to find out that the person is or that player is going for play or not based on the weather condition. So this is the data set, and here total 14 entries are there, and weather contain three types of values like rainy, sunny and overcast. And for that rainy, the output feature is there, or the target variable yes no. This is the classification kind of problem, so that's why yes no values are there. So what is our step 1? Step 1 is saying कि convert given data set into the frequency table. So here you can see for this data set we are converting this data set into the frequency table for weather variable. So for weather we are having yes no value, so that's why we have written here yes no. And in weather three values are there like overcast, rainy and sunny. So here you just go through the data set and see for overcast how many yes are there. So you can see for overcast all 5 yes are there and 0 no's are there. Similarly for rainy you can see for rainy 1, 2, 3, 4. You can see the blue color rows. So 1, 2, 3, 4. Total 4 are there, and out of that 2 yes and 2 no's are there. For sunny 3 yes and 2 no's are there. So what we have done here, we have calculated total yes. So total 10 yes are there and total 5 no's are there for the weather. Now, the second step is create or generate the likelihood table by finding the probabilities of the given feature. So, for the same data set, what we want for that earlier steps, we want to add on the likelihood table. So, here we are calculating the likelihood of this weather feature. So, here again you can see the similar table we have continued here. I want to calculate the likelihood for the overcast. So total number of values like 0 plus 5 is 5 divided by total values. So total are 14. So 5 divided by 14 equal to 0.35. For rainy, again 2 plus 2 is 4. 4 divided by total entries. So total values in total records in the data set are 14. So 4 by 14 equal to 0.29. For sunny, it is like 2 plus 3 equal to 5 divided by 14. So which is equal to 0.35. So here we have calculated the likelihood for all the feature values like overcast, rainy and sunny. So similarly, we are calculating the likelihood for no and likelihood for yes. So how many no's are there? 4. 4 by 14 which is equal to 0.29. And here likelihood of yes is 10 because here 5 plus 2 7, 7 plus 3 is 10. So 10 divided by 14 which is equal to 0.71. So this is how we are calculating the likelihood. Now moving to the third step, that is the now we are using the Bayesian equation to calculate the posterior probability. So final formula we are writing here for this. So you can see here. Now what I want to map the Bayes theorem into this equation for this problem. So here the problem is the player will play if the weather is sunny. So that means I want to calculate the probability of yes given sunny weather. So for that again I am writing. So here you can see this is what our A and this is what our B. Sunny is our B. Now we are just mapping all this value into this formula. So here you can see probability of yes given sunny is equal to probability of sunny given yes into probability of yes and divided by probability of sunny. So simply mapping we have done here. Now we know the value of this like probability of sunny given yes. So how many sunny records are there? So total for yes, so you can see sunny, this is one yes, the next one is the this one and one more is there this one. So here you can see 1 2 3, so 3 divided by total yes. So in our case total yes are 10, so 3 by 10 equal to 0.3. So similarly we are calculating the probability of sunny. So we have already calculated in the likelihood table, so that we are taking, and probability of yes is 0.71. So this is how we are calculating the probabilities. Now here you can see with the help of this, so we are just writing here probability of yes given sunny is equal to and the value. So we are getting 0.60 as our final values. So similarly, we are calculating the probability of no given sunny. So yes or no, both for classification we are calculating for both. So yes, we got the 0.60 and for no we are calculating. So again similarly, we are just mapping the values. So probability of sunny given no, so we are getting it as a 0.5, probability of no as a 0.29 and for sunny it is a 0.35. So now we are calculating the final one which is equal to 0.41. So you can see in the earlier case we got the 0.60 and now we got the 0.41. So here you can see the probability of yes given sunny is greater than probability of no given sunny. So that's why we are saying on sunny days player can play the game. So this is how we are applying the Naive Bayes classifier to the classification problem. So here whichever value is giving the higher probability, so that we are considering. Now we will see where this Naive Bayes classifier is used. So here it is used in the face recognition. So as a classifier, it is used to identify the faces on its other feature like nose, mouth, and eye. It is used in the real-time prediction. So it is used in like making predictions in the real life. The next one is the multi-class prediction. So this algorithm is used for the multi-class prediction feature. Hence we can predict the probability of the multiple classes of the target variable. Next is the text classification, spam filtering, sentiment analysis, and the recommendation system. So this neo-Bayes classifier, a collaborative filtering, and this Bayes classifier. So both are used for building the recommendation system. And medical diagnosis. So here doctor can diagnose the patient by using the information that the classifier provides. So for classification, like what type of disease is there, for that we are using the neo-Bayes classifier. Now we will see the advantages of the neo-Bayes classifier. So first of all, it is very easy, simple, and easy to implement. Now the second one is can be used for both binary and multi-class classification problems. Data, so the training is taking the less time. So here we are assuming that the assumption is like the features are the independent. Independence is hold. So that's why the classifier perform better compared to the other machine learning algorithm like logistic regression, decision tree. So now we will see the disadvantages of the neo-Bayes classifier. So neo-Bayes assume that all the features are independent or unrelated. So it cannot learn the relationship between the features. The next one is this is very important problem. So if the categorical variable has a category in the test data set and which was not observed in the training data set, so then model will assign a zero probability and will not be able to make the prediction. So this is called as zero frequency problem, and for solving this problem we are using that Laplace estimation smoothing technique. Now we will see the type of the neo-Bayes classifier. So the first type is Gaussian neo-Bayes classifier. So here this Gaussian model assume that the feature follow the normal distribution. So this means that if the predictor takes the continuous value instead of the discrete, then the model assume that these values are the sampled from the Gaussian distribution. Now second one is a multinomial Navier-Bayes theorem. So again it used when the data is the multinomial distributed and commonly used for the document classification problem. So here the classifier uses the frequency of word for the predictors. Now the Bernoulli-Navier-Bayes. So here this Bernoulli classifier works similar to the multinomial Navier-Bayes, but the predictor variable are independent Boolean variables. So here that predictors are of the Boolean like yes, no, 0, 1 likewise are there and used when data is as per the multivariate Bernoulli distribution. Now take a pause here and tell me what is the key assumption of the Navier-Bayes classifier and how does it impact its performance. After done, resume the video. So here this Navier-Bayes classifier assume that all the features are independent. So this is the assumption of the Navier-Bayes classifier and which simplifies the calculations but not hold true in the real world data. So potentially leading to the inaccurate predictions. So these are the references that I have used. So this is all about the Navier-Bayes classifier. Thank you.